So now we're going to look at something called the substitution method. And the way the substitution method works is that we substitute one equation into the other to solve the system of equations. So let's see what that would look like. And here's an example. I gave you two equations, x minus y equals -3 and y equals 3x plus 5. Notice, this time, this second equation actually is not in standard form. It is in slope-intercept form. And so whenever you see something like this, and if you're asked to solve it using whichever method you want, this is the way that you would want to use the substitution method, because this will fit in nicely for substitution. If you have things that are in standard form, then the elimination tends to work really nicely. But my first step is going to be the same that it always is, and that is to label my two equations. So I label equation 1 and I label equation 2. And what I notice is that I can take my equation 2, and wherever there is a y in equation 1, instead of writing y, I can write 3x minus 5. So I'm substituting equation 2 for y into equation 1. So here I had equation 1 was x minus y, but y is 3x plus 5, so I put in 3x plus 5. Notice, I put parentheses around this because I am subtracting all of y, and all of y is 3x plus 5. So I need to put parentheses. If I don't, then I won't be subtracting all of this. And when I do that, I need to remember to use my distributive property and distribute that negative. So I get x minus 3x minus 5 equals -3. Combine like terms, so I get 2x minus 5 equals -3. Then solve for x. I solve it all out, and I get x equals -1. Now, after I get x equals -1, I'm only halfway there. I need to go back and find out what my y is equal to. So I can choose any equation I want to find my y. I actually chose my first equation this time, and I put -1 in for x, minus y equals -3, negative y equals -2, divide both sides by the negative, and I get y equals 2. So my solution is -1 and 2. So here's another example that they might say solve for using substitution for this system of equations. And what I notice is, hey, the system isn't set up nicely for solving using substitution. So I'm going to need to change one of these equations to say either x equals or y equals. It doesn't really matter which one I choose. I decided to choose equation 1. So I labeled that equation 1, that equation 2. So I changed equation 1, and I'm going to solve it for x. It doesn't matter, but I rewrote equation 1, and I changed it, and I just moved the y to the other side, and it became x equals 5 plus y. And equation 2 is x plus 2y equals -1. Now, I have decided that I'm going to put equation 1, where it says x equals, into equation 2. So wherever there's an x in equation 2, I'm going to rewrite it and put in 5 plus y. So here was equation 2, and it started off with x, but I changed this x to be 5 plus y. Plus 2y equals -1. Don't forget to put that plus 2y in there and the -1. You got to put all the rest of it back in. Well, now I'm just going to combine my like terms, and I solve for my y, and I get y equals -2. There's the steps for solving. That was way back from chapter 1 and 2. Well, I'm not done. I found my y, but now I need to find my x, so I can go back and pick any one of my equations. I chose to use this equation here. And so I went back in, and I solved it, and I got x equals 3. So my solution is 3, -2. Here's another example. Equation 1 is 10x plus 2y equals -6. Equation 2 is y equals -5x. I decided to take my y, and wherever there was a y in equation 1, I rewrote it, and I stuck in -5x for my y. So I rewrote equation 1. Y had been right there. I rewrote it and put in -5x. I solve my equation, and I get 0 equals -6. Hey, that is not a true statement. So what does that mean? That means there is no solution, the lines are parallel, and I can write that little symbol, or I can put no solution. Now, I could also have a problem that looks like this. Negative 4x plus 2y equals negative 10, and equation 2 is y equals 2x minus 5. I'm going to substitute where there is a y, the 2x minus 5. So I went in here and back into equation 1. I substituted 2x minus 5 for y. I go ahead and use my distributive property first. I solve and get my variables. So, hey, they canceled out, and I got negative 10 equals negative 10. Hey, that is a true statement. When I have a true statement and there's not an x and a y, then I say my lines coincide and I have infinitely many solutions.